Hi everyone, welcome back to Deep Forum. And today we have Oles Petri from Reface to share with us some of the cool things that the project are doing. How are you doing, Oles?
Great, thank you for invitation and intro.
Our
And
pleasure. So take the floor. The stage is yours.
uh, yeah, I will start.
Yep.
Hi everyone. My name is Oles Petriv, and I am a CTO of Reface. Um, Reface is a company focused on commoditizing generative adversarial networks and different methods how to manipulate video in a funny way. Uh, right now, more than 100 million people already use Reface. Last year, we hit top one position in the US App Store. Um, Also, Reface was selected as one of the best app in Google Play Store. We are the team of 150 people, which are playing around with high-end tech related to generative adversarial neural networks. What is generative adversarial neural network? Every every image you see right now on my screen is fully synthesized by neural network. So no real pixel of actual photo of actual real world um, are not on these images. So how neural networks works, especially generative adversarial neural networks. Main idea that uh, fuel all these hype around generative adversarial network, deep fakes, and so on and so on are is pretty straightforward. Um, you have two neural networks. One neural network try to define which sample is sampled out of real distribution of some images and which sample is synthesized by other neural network. And second neural network generator um, tries to confuse first neural network discriminator. And as a result, in this game, discriminator is training to be more and more precise in detecting of real and not real images, and generator trains to produce more and more realistically looking results. And as a result, you can synthesize these naturally looking images out of pure noise. If you add to this pipeline not only some random noise, but input image as a condition, and increase complexity of this pipeline a little bit, you will get a method of how to train neural network in a way that will allows you to modify any image in pretty high level controllable manner, like modifying on the image only identity features without modifying appearance, color, and so on. And having such neural network, you can modify any identity on any image to produce such strangely looking things, um, like this Morgan Freeman in this pretty strange image. um, that's cool, but everyone is concerned about security of all this stuff and possible misuse of this tech and deepfake. This buzzword, I think everyone heard a lot for last 2 or 3 years. And how about dealing with detecting of these altered videos? There are some data sets constructed precisely to target this issue of recognizing which image is manipulated by a neural network and which image is not. Uh, and there are even different contests with prizes, pretty big prizes, with goal to create a pipeline or additional neural network that can define with high confidence, is this video altered by some generative adversarial network or not. But if you will look at leaderboard and actual results of such approaches to detect any possible modification of, for example, facial image using generative adversarial network, you will find that accuracy of such networks are pretty bad as as of some source of high confidence that this video is real or not. And we think in Reface, we think that this is ill-posed problem from the very beginning, because this is old story about virus and antivirus. You will never get 100% efficient antivirus, or even if you will get at some day 100% efficient antivirus for all possible viruses, the next day, first thing that will be able to hijack this detection system will discreditize all authority this system will get. So we think that better way of dealing with such thing as deep fakes or manipulated videos is not to fight them with antivirus methods, creating some universal detection system that will show everyone that, yeah, this video is real or this video is not real. But instead of it, what we want to show is a method of providing technology in a pretty easy way, as easy as possible, so anyone will be able to modify any video as he wants, but controlling technology that's providing millions of people to manipulate some visual content. You can imprint in every result of such manipulation. You can imprint invisible digital watermark. This is an illustration of one of possible method of digital watermarking. There are plenty of approaches how to create robust digital watermarking. And if you are a provider of technology, which is easy to start, so anyone without additional GPUs, some machine learning background, or some special skills can use this technology, will imprint watermark that result of applying this technology to this particular video is a synthesized result, not a real video. Will increase amount of verified altered video orders of magnitude more efficient than this universal antivirus approach. So instead of being able to detect any possible altered video in the internet and said that this is real video or this is not, we want to create a system that can detect only our videos, but with extremely high confidence. So some numbers, which method is more efficient? Um, at June of 2020, in all internet, there was something around 200,000 videos with altered identity in all internet. And 1,500 out of them was a result data sets for deepfake detection, like this data set created by Google, Facebook, or Microsoft, and only something around 15,000 of videos was created by some underground deepfakers to create some deepfake videos. Remember that accuracy of universal deepfake detection tools is something around starting from 70% up to 90%, depending of method of and different alteration of these videos. Right now, at March of 2021, there are more than 3 billion of videos with altered identity, and something around 3 billions of them created by Reface. And in every video created by Reface, there are invisible digital fingerprint that is easily detectable by our detection system, which allows us to define with extremely high confidence that such video is a result of Reface. We don't know is it real or not, but we know for sure is it Reface result or not, and we think that such method of minimization of possible misuse by fingerprinting result of your technology and commoditizing this technology as much as it possible is way more efficient method of minimization of possible issues related to this generative method than this universal antivirus approach. So being able to detect only our videos, we are able to detect 99% of all altered video with modified facial identity. But being able to detect all this modified video is a cool thing, but I think that way more better effect on all market is not a ability to detect some technology, but example of how to use technology in a funny way that without harm to anyone. So you know, if you created a knife, with knife you can kill people easily, but 99.9% of all knife usages is to create your to make your toast or do something with your bread. So what we are doing in a Reface, we showing example how these pretty impressive tech can be used in a funny way, for good, not for bad, to create new pattern of technology utilization, instead of creating some videos that are trying to mislead someone about politics or something else. We are commoditizing methods of creating fun out of this tech, and making visual world more controllable. Second part of my presentation is not about detecting and recognizing deepfakes, but about future of generative media. I think that right now we are on a pretty interesting stage of evolution of media at all, because all existing neural networks allows us to create whole new layer of abstraction on top of all existing visual content. Um, for now, visual content like videos or images is a collection of pixels on a screen with in a pretty low level representation. But neural networks, when they are trained in the right way, allows us to transform these raw RGB pixels into high-level abstraction masks and labels, like instance segmentation mask, like depth maps, like normal maps, object bounding boxes, and so on. Or like in a dense pose, these pseudo 3D grids around every human in the video, which allows us to interact and manipulate these videos in a pretty high level and highly abstract way, not just by modifying raw pixels. And we think this is a first step of whole recontextualization of visual content, because fitting image and video content through whole cycle of different neural networks with different output labels transform all already created visual and video content into some sort of computer game, where you can interact and manipulate different parts of video or images in a pretty interesting way, where manipulating with the label of a video or image, modify content of this video, allows you to create something new out of already existed static video file. And adding these high-level landmarks, semantic segmentation masks, and all these high-level, highly abstract labels that allows you to control in a meaningful way these labels, and using neural networks to transform these high-level labels into these low-level RGB pixels you're seeing on the screen, makes every image or video some sort of result of co-creation. Like on these images, you can see how pretty simple generative adversarial network that was trained on a pair of images, raw RGB images of myself, and high-level key points of joints and key points of a face. Neural network is trained to modify these image of landmarks into RGB image of myself. So manipulating these joints landmarks allows us to manipulate human pose and the final image of actual person. And think that we right now we are on before right before next breakthrough in the way we interact with content. For thousands of years, process of content creation was pretty straightforward. There was also author of some content like drawing on a key on a wall in a cave. There was some tech used to do this act of content creation, and as a result of this act of content creation, there was some content, piece of material world with the imprinted idea of author during content creation by technology. And then consumer consume these ideas and abstracts out of this piece of material world during process of content consumption as a guy that is looking on this drawing on the wall. Then additional technology like language, printing, all our media for the last 200 years modified a little bit this pipeline by creating multiple copies of this fingerprint of idea in the material world and minimizing amounts of resources and time for different consumer to consume this content. Next big breakthrough, as for me, was computer rise of computer games, because computer games in one way is pretty similar to, for example, movies or images or books, but there are another stage when technology is integrated in this pipeline. After creating multiple copies of this game, technology, for example, computer or console, is utilized during content consumption, adding additional stage of content interaction. Consumer during playing the game interact with this static copy of game, creating some new, a little bit personalized experience, which then transformed into some actual image on a screen, and then this image on the screen is consumed by consumer, and it allows consumer to be part of co-creation of new experience that wasn't already created by game developers on the first stage, because player can do plenty of different things out of a scope of idea of original game. And
Sorry, Olive.
yeah,
We
yeah.
need to wrap up.
Oh, excuse me.
We need to wrap up. The time is running out.
Okay, so
Sorry.
I'll be fast. And then, as a result of creation this personalized experience of playing the game, player want to share his own experience of playing the game, and that's cool. But creating each new piece of content like a computer game is extremely hard, because you need to spend a ton of resources to create each new game. But fitting existing visual content we already created for last 200 years, a lot of visual content like movies, images, and so on, feeding them into neural networks, manipulate them by highly abstract methods of customization and interactivization of this content, can modify all existing content and transform in some sort of computer game. Like, for example, this video of Victoria's Secret Angel girls are shared by two different people. One video is shared by some pretty girl with the intent of take a look how I'm pretty in this Victoria's Secret Angel look, and same set of videos but shared by some guy with a totally different intent. Like, guys, take a look. This is pretty funny, and intent of sharing same technology, same set of videos are totally different. So this create whole new type of content consumption, like content recontextualization, create new angle by which people can interact with this content and bring whole new life into already forgotten memes, movies, and so on, and recontextualize this visual content again and again in totally new ways by firstly extracting these high-level landmarks and labels, and then using generative adversarial neural networks to modify this content in a natural way. So thank you.
Thank you, Oles. Thank you for sharing such in-depth tech in Reface. Thank you very much. And guys, we're back